Thank you so much for joining us for our second You've Got Perseverance webinar. My name is Lindsay McLaurin, and I am a public outreach specialist for the Mars program at NASA's Jet Propulsion Laboratory. We're just so glad that you've joined us today. On behalf of the NASA's Perseverance rover mission, today we are honoring 20 students that have shown the unique quality of perseverance in their educational journey. It's not necessarily about the best grades. It's about having the grit and determination to continually improve and to do the best that you can. So how did we all get here? Let's watch our video where we ask the country, do you know someone who has perseverance?
NASA wants to know, what does perseverance mean to you? Our Perseverance Mars rover and mission teams already know quite a bit what it means to persevere. We found a way to launch the rover from Earth in the middle of a global pandemic. And since surviving the trickiest Mars landing yet, we've continued to overcome unexpected challenges in day-to-day operations and collecting and storing our first rock samples for future return to Earth. When you set your mind on a goal and stick to it, you can accomplish almost anything. Do you know someone who has perseverance? NASA is looking for nominations of middle school students from around the country who've kept moving forward when the going got tough. The You've Got Perseverance Award highlights the grit and determination of the next generation of explorers. Awardees will get to chat with NASA experts and even get a once-in-a-lifetime personalized message direct from the Perseverance rover on Mars. We can't wait to hear how you've got perseverance.
We asked and you answered. People from all over the country nominated students that they were inspired by. Each of you, 20 awardees in total, have your own unique stories and challenges and showed us how you persevered to make the most of the opportunities that you were given. As part of our congratulations, you will soon hear from members of the Perseverance rover mission. They will talk about some of the rover's incredible accomplishments and also share the personalized messages that the rover sent to each of you all the way from Mars. Then a little later in the webinar, we will have time for each of you to ask a question of a team member. Now let's go over to Mission Control and meet Robert Hogg, Deputy Mission Manager for the Perseverance rover.
Thank you, Lindsay. Hi, everybody. I just wanted to say congratulations on what you've done. You are all amazing, and we are very happy to see you here with us. We are in Mission Control for the rover at JPL, and behind me are members of the Perseverance team, and they're in Mission Control, so I'll ask them to wave and say hi. Thanks, everybody. And so this is where we control the rover and the Ingenuity helicopter from. So first, let's just talk about the mission a little bit. So go ahead and roll that video. Perseverance, the rover, is NASA's 5th and most advanced rover to explore the surface of Mars. And it was designed and assembled and tested here at NASA's Jet Propulsion Laboratory in Southern California. And it landed on Mars just over a year ago on February 18th. And so you can see video from the landing. This is from Mars that's looking down at the rover as it lowered down to the ground. And so we had a successful landing, and then we took our first images of Mars around the rover, and that's what you're seeing here. That is from another planet. And this is a selfie that the rover took of the first rock that we drilled and that we got samples out of. So we have just been really happy and really thrilled at everything that we've done with this amazing rover and this amazing helicopter over the last year. Some of the things that we've done is we got everything working on the rover first, and we checked out all the hardware and made sure the robotic arm was working and the drive wheels. And then we got moving and we started looking for really interesting scientific areas where we could take samples to be prepared to be brought back to Earth. And so since we started driving, Perseverance has driven over 5 miles. As of yesterday, it passed the 5-mile mark. And then, of course, Ingenuity, the helicopter, did the very first flight on another planet. So now we can say that we can fly on other planets. And it didn't just do one flight, it flew 24 times since then, which is way more than we expected. So how do we do all of that? Let's see, go ahead and bring up the communication sheet. Thank you. So we have a network of big antennas at different places around Earth. And we send our commands to the rover and the helicopter through those antennas, the deep space network, directly to the rover. And then it waits to get the commands in the morning on Mars. It wakes up on Mars, it receives the commands, and then it do that day. So then it carries out its instructions, it does some driving, and it does science measurements of rocks and the area around it. And then it reports back to us by sending the data and the images and the pictures back through 4 different orbiters that are basically just like satellites that are orbiting Mars. And the orbiters then send the data back to our deep space network, and we get it here in mission control. So that's what makes this mission control room so exciting. We're in here every day and we get to see the images and the pictures, and we get to find out what happened every day. And so yesterday we discovered that we drove a long way over the weekend. All right, so let's see. Now we're going to talk about how we were able to send your messages to the rover to Mars. So what you're seeing here is some of the examples of how we send commands. And so the messages are sent from the Deep Space Network to Mars and to the rover. And then the rover receives those commands and follows the instructions. And so then we sent your messages to the rover, it received them, and then it sent them back here to Mars with us. And so I'd like to introduce now the head of our project. She's the project manager, Perseverance mission and the Ingenuity helicopter, Jennifer Trosper.
All right, thanks, Robert. Well, it's great to be here with all of you guys. I see you in the Zoom meeting here, and I just want to say to all of our winners, congratulations. I read through your stories. Your stories inspired me. You've gone through a lot. You've overcome so many challenges. And we're just excited to be here to honor you today. And as Robert said, those messages that Perseverance sent down were messages that we wrote to honor you and honor you for the difficult challenges that you have overcome and for the accomplishments that you have made. So congratulations to all of you. It's great to see your beautiful faces on this call. And I want to just remind you that even the Perseverance rover was actually named by a middle schooler just like you. So Perseverance got its name because this middle schooler was thinking about what we need as humans, and he thought about the fact that no matter what kind of challenges are put in our pathway, we always need to persevere. And that's how the Perseverance rover got its name, and that's how you got selected to be our honorees today. You've always persevered, and we can see how you've persevered through many challenges. Now, the project has had to persevere. The rover has had to persevere as well. And I'll just tell you a few things that have happened to us during development. So that means when we're building the rover, the heat shield, when we were testing it, actually broke. And we didn't have a lot of time before we were going to launch. So we had to build another one very quickly. And another thing, one of our ovens, when we were doing thermal testing for one of our instruments, the oven broke. And we had to rebuild that instrument. So things happened and we had to do it in time for our 2020 launch. We also did all that during COVID. And then our very first sample, we drilled a hole, we went to get the sample, and our sample tube came up empty. And so there's a lot of lessons learned there, but we have 8 rock samples now. And so we have learned how to overcome those challenges as well. So with that, I would like to share the messages via video that the Perseverance rover sent from Mars for all of you. So maybe when you're out at night, looking up in the night sky and you see Mars, you can think about that message directly to you being beamed from the Perseverance rover, encouraging you to continue to persevere. So congratulations again to all of you. We're very proud of you. And now I'm going to hand it back to Lindsay for some Q&A.
Thank you so much, Robert and Jennifer, for speaking with us today. And those messages from the rover, it's so exciting to know that, we can send messages all the way from Mars to Earth. I'm sure that inspired some questions from each of you. So now is your chance to ask some of the Mars team, some of the questions that you've had, whether it's about robotics or their career path. And so for those of you watching, you can raise your hand with the little hand raise emoji that you'll see on your screen, or you can ask a question in the chat. And I will pass it over to Robert and Jennifer and some of the mission team members to answer your questions. So if we are ready, does any of our awardees have a question they would like to ask a member of the team? I see Stacy's hand is raised. Who do you have with you today, Stacy?
Hello.
Hello, we can hear you.
Hello. Yeah, I can ask a question, right?
Yes, absolutely.
All right. One of my important questions. When are you gonna send people on Mars?
That is a great question. Actually, so I will have Dr. Rick Welsh answer that one. Rick, if you're on.
I am on, and thanks, Robert. That is a great question. I think we're all interested after seeing our robotic explorers get to Mars to when people might go there, but it's probably still 10 years before we actually get people to Mars. So you're just the right age. So if you work hard, I think you'd be a good candidate for an astronaut to Mars.
Totally agree.
Thank you so much. Caitlin, would you like to ask your question to the team?
How long did it take to complete the Perseverance rover?
Let's see. Who do we have on who can talk to about that? How about Luis Gendura? Can you hear us? Why don't you describe that?
Could you repeat the question, Robert? I was reading the questions in the chat and I missed the question that was out loud.
No problem. How long did it take to make the Perseverance rover?
So 7 or 8 years we all worked, first with early concepts and then some development hardware to learn how things were going to work. And then we built up flight-like hardware and then flight hardware and put it through a rigorous test program before it launched and landed, and we use it on Mars. So it takes a while.
Thank you so much for that answer. Billy, would you like to ask your question?
What is the climate like on Mars?
Oh, good question. Let's see. We need a scientist here. Dr. Ken Farley is the lead scientist for our whole project, our whole mission. So maybe he can answer that one for us.
Sure. The current climate on Mars is extremely cold and extremely dry. It's colder than almost anywhere on Earth except for in the polar regions, and it is drier than the driest desert. So it's a very inhospitable place. But one of the fascinating things is that where Perseverance is exploring, the rocks there were deposited in a lake billions of years ago. And that tells us that Martian climate has changed enormously over the history of the planet.
That is such an interesting answer. Miguel, would you like to ask your question?
What was
It's all right. It happens to all of us.
What was the process of the rover?
What was the process? Could you say that again? Sorry.
Miguel, would you repeat your question, please?
Yeah. What was the process?
He froze up, Robert, but I think he was asking what was the process to making the rover.
That's a great question. All right, good to know that we froze up over here. We'll work on that. So let's see. Let's have Lauren Jones answer that one. Lauren, if you're still on.
Yes, I am. That's a nice, easy one. Thanks, Robert. Let's see. The process for making the rover. So we start off with ideas, then we put them on paper and we talk about them a lot of talking. And then we all decide on what the best ideas are and we start analyzing those, and then we'll build models. We'll make small models and we'll make bigger models and we'll make life-size models, and we test those to make sure that they do what we think they're supposed to do. And then finally, we put them in the same environment that we're going to see on Mars, like Dr. Farley explained, and make sure that they'll behave nicely in that environment. And then we get to test it all together in like a completed rover. And finally, we launch it and get it to Mars. That's the short version of 8 years of our lives.
Thank you so much, Lauren. Grayson, would you like to ask your question?
Where did some of y'all go to college and what did y'all study?
Oh, really good question. All right, let's have Iona answer that one. Go ahead, Iona.
Sure. I went to college in upstate New York in the freezing cold at Cornell University, and I studied mechanical engineering.
Yeah, so we've all been to different colleges and studied different things, and there's the folks here in this room and online know a lot of different areas, a lot of engineering and a lot of science, and different levels of degrees, and so yeah, big range of experience there.
Awesome. And I am sorry if I mispronounced your name, but Alessia, would you like to ask your question?
It's Lassia, and what goals do you have for building the Perseverance rover? I think there's
Goals we have for building the Perseverance rover. So I'll answer that one. We many years ago had the idea to go to Mars and find samples of Mars that maybe showed signs of ancient life, of like bacteria and different signs of life. And so we've been talking about that here at JPL for many years. And so we decided to put a rover together that could go and drive long distances and have really amazing science instruments and cameras so that we could go find the best places to look for that. And so we needed a big rover that could drive a long way and carry a lot of equipment and be tough and be able to withstand extreme heat and cold and all the vibration and stuff when you're launching something on a rocket. So we took all those things into account when we were doing the design and building our rover.
Thank you so much, Robert. Chloe, would you please ask your question?
Hello, thank you for this opportunity. I was wondering if the rover experienced any difficulties within its first year on Mars, and if it did, how did you overcome it?
Great question. All right, let's see. Who would like to answer that one? Actually, I think I'll have well, I can handle that one. So it's one of the first interesting things that actually take that back. You know what, Brooklyn, why don't you talk about our first fun sample tube?
So the first time we tried to collect a core sample, we went and did the drilling, tried to collect the core, went to go take some pictures down the tube, and realized that there was no core. And so we had to kind of stop and reevaluate and figure out, where did the core go? Did we drop it somewhere? Did we just not collect it? What happened? And so we wound up having to kind of turn around and reevaluate what kind of rocks we wanted to look at and how we want to actually do our coring. And then the next core collection was super successful, and we collected a nice size core.
Thank you so much, Brooklyn. Aslyn, would you like to ask your question, or would you like for me to do it for you?
Why did you send a helicopter to Mars with Perseverance?
Good question. So let's see if there's any heli folks on the line. All right.
We
Well,
did have Teddy join.
oh, fantastic. Perfect. Sir Santos, go ahead, take that one.
Sure. So we sent a helicopter to Mars. We sent Ingenuity, our very first aircraft sent to another planet. And the purpose of Ingenuity is to prove that we can fly. We've sent rovers. We're very good at sending rovers. We're doing a lot of exciting science with rovers, but we've never flown on Mars before. So the purpose of Ingenuity was to prove that we could, so that in the future, when you all grow up and go to college and study engineering and physics and robotics, you guys can build fleets of aircraft that will be flying around on Mars one day.
Great. Thank you for that awesome answer. Krisha, would you like to ask your question or would you like me to do it for you? I sure can ask it for you. Let me find it one more time. So Krisha would like to know, how many designers and experts worked to develop the rover? How long did it take to make the rover?
All right. Let's see. Justin Mackey, I'm going to put you on the spot. Why don't you take a shot at that? How many designers and experts and how long did it take?
Okay. It took thousands of people, all of whom had a lot of expertise from all over the country and all around the world. And it took, I think somebody had mentioned, I started working on this project 8 years ago, and I know that people had already been working on it when I joined 8 years ago. So it took at least 8 years, 10 years, and we build off of previous missions. So the short answer is thousands of people and at least a decade.
Thank you so much, Justin. Sophia, would you like to ask your question? Sophia, if you would like to ask it yourself, you can, or if you prefer me to do it, I can ask for you.
I see hers in the chat.
Okay, I'll ask it for you, Sophia. In the future, do you think NASA will be able to explore planets or moons further than Mars with robotic exploration? It's a very good question.
Amazing question. Jessica Samuels, I see you on. Would you like to answer that one?
Hi, yes. Hopefully you guys can hear me okay. We are always looking to explore and all the bodies in our solar system. And we are currently exploring with orbiting spacecraft. And in the future, we hope to also put a lander, particularly on one of Jupiter's moons, Europa. So that's a new exciting robotic exploration for us in the future.
Thank you so much. Owen, I have a question that you submitted before, but I want to give you the opportunity to ask yourself if you would like. No, that's okay. I'll ask it for you. So Owen would like to know what improvements were made between Curiosity and Perseverance.
Great. Let's see. I think I'll have Dr. Justin Mackey talk about that one.
Okay. Probably the biggest improvement that most people notice are in the cameras that we have on the rover. This particular camera, or this particular rover, sorry, we flew the mission with 23 cameras and then 2 more on the helicopter, so 25 total. The rover itself has 19 cameras. So if you think about your phone, you have a forward-facing camera and a rearward-facing camera. The rover has that, and 17 other cameras. And we have cameras to look at the sample tubes. We have cameras on the end of the arm. And so that's our biggest improvement from my point of view. I actually work on the cameras, but the rover itself has improvements all over the place, has better wheels, has a sampling system that is incredibly sophisticated, and just about all over the rover you can find improvements.
Thank you again, Justin. Celeste, do you have a question for the team? Okay, Celeste would like to know, with the samples that are collected, what will be the next step?
Fantastic question. Let's see. Ken Farley, would you like to field that one? Dr. Ken Farley.
Perseverance is going to collect something like 35 rock samples. We only have a few on board. We filled about 10 of our sample tubes so far. And the hope is that they will come back to Earth on future missions. Perseverance is not responsible for bringing them back, but future missions that are presently being discussed by NASA and the European Space Agency, those missions may bring those samples back in the beginning of the next decade. And once they're back on Earth, they'll be analyzed with the full diversity of scientific instruments that exist on the Earth.
Thank you so much, Ken. Leo, would you like to ask your question to the team?
Yeah, so my question was, why does NASA believe space travel is important?
Oh, that's a good one. All right, I'm gonna ask Steve Lee to give us his philosophical answer to that one.
Thanks, Robert. That's an excellent question. And I think you all have a lot of curiosity, or you wouldn't be in this call and wouldn't have persevered like you have. And that's just part of human nature. We are very curious. We really want to understand the universe. And now we are at the cutting edge of exploring the universe. And that's one of the key reasons why NASA wants to go and understand better other worlds like Mars. There's initiatives to send humans back to the moon to go explore the moon. And as Jessica mentioned, we have missions to we already sent missions to all of the planets, at least to fly by for an initial reconnaissance. And now we're sending orbiters there to spend more time and look in more detail. In the future, we'll be spending landers, and we'll just learn more and more about our solar system and about the universe and our place in it.
Thank you, Steve. Eliana, would you like to ask your question to the team?
My name is pronounced Elena, and I want to ask the rover, what's its biggest discovery that it has found on Mars?
Oh, wow. Okay, so for that one, I'm going to ask our project scientist who's responsible for that whole thing. Go ahead, Dr. Farley.
Sorry, could you repeat the question, Robert?
What is the biggest, sorry, can you ask that again, Elena? The biggest discovery, right?
What's the biggest discovery that the Perseverance rover has found?
Amazing. What is the biggest discovery that the rover has found?
Got it. I mentioned earlier that we landed in a crater that once hosted a lake. And we believe that the rocks that we landed on would be sand and mud deposited at the bottom of that lake, sedimentary rocks. After spending a year driving across them and studying them, we have come to the realization that they are not sand and mud at the bottom of the lake. The rocks are actually probably lava flows or similar kinds of igneous rocks. So that tells us that what we thought going in was wrong, and that's the nature of discovery.
Thank you so much. Sky, would you like to ask your question to the team?
Is it possible that larger aircraft could fly on Mars in the future?
I think your question was, and you just double checked me here, is it possible for larger aircraft to fly on Mars in the future? Is that right?
Yes.
Good question. I think I'll ask the group supervisor of the aerial vehicles group, Teddy.
Thanks, Robert. So yes, and we are working on that actively. Even before Ingenuity had its maiden voyage, we started designing larger, more capable vehicles for future flight at Mars. The largest that we're looking at right now is actually a hexacopter. If you guys have seen hexacopter drones flying around here on Earth, very similar designs where you have 6 rotors around a central body. And it would be much larger than Ingenuity. It would actually be bigger than the rover itself. So each one of the 6 rotor blades is approximately the same size as Ingenuities that we're designing. And this concept is called Mars Science Hexacopter. And the hope is that when you go to larger platforms, you can carry more weight. And one day you'd be able to carry actual science payloads and be able to fly up a cliff wall or down to a cave, go to areas that rovers or other aircraft might not be able to get to. So yes, it is possible, and yes, there are teams of people excited to work on that for the future, and hopefully including you all listening today.
Thank you, Teddy. Vicky, would you like to ask your question to the team?
What is your favorite fact about Mars or the rover?
Favorite
fact.
Favorite fact. Thank you. Great question. Justin Cook, I see out there, would you like to answer that one? Favorite fact about the Mars rover?
Favorite fact. Well, I'd say something new that we have not talked about. That's a new instrument on the Mars rover that takes carbon dioxide and makes liquid oxygen. So to me, that is just something that's very cool that's going to help us do when we put people on Mars, how do we sustain them? And that's one instrument that we were able to test on Perseverance, and it was successful. So we've been able to illustrate that capability. And to me, that's pretty cool.
Thank you, Justin. I just want to check before we go on for maybe some second round questions from the students. Are there any students that have not asked a question yet that want to ask out loud to the team, or you can put it in the chat? No? Okay, Billy, you can ask your second question. Billy, did you still want to ask your next question?
How close are you to SpaceX?
Let's see. So SpaceX is a commercial company, and JPL is a NASA center that's a government company. So NASA is a government institution, and so we work with SpaceX. NASA works with SpaceX very closely, and they've been helping us launch stuff off the surface of the Earth, and so we work with them on a lot of stuff. So we're pretty close.
Thank you, Robert. Tristan, would you like to ask your next question?
Okay, I have a question. Do you think they might be aliens on Mars or other planets they might discover with the Perseverance?
That is an amazing question, and that's why we do these missions. So I'm going to ask our project scientist again to field that one, since he was asked by Congress members that same question. So you're in good company.
Yeah, I have been asked that question before, and I'll tell you that I have a kind of a secret fear or dream, I'm not sure which, that we will drive around a rock and find aliens behind it, but not very likely. The climate on Mars to life as we know it at that level. What we are looking for is in these ancient rocks when Mars had water on its surface, looking for evidence of microscopic life. If there ever was life on Mars, we think that is the most likely kind of life that would be there.
Thank you, Ken. Sky, you can ask your next question.
How would you grow plants on Mars?
How would you grow plants on Mars? Let's see, Justin Mackey, do you want to take a shot at that one?
Sure. If you did want to try to grow plants, and people have proposed trying this, you would need to take some nutrients for the plants themselves. Plants actually take CO2 from the atmosphere and convert it into oxygen. So there is already CO2 on Mars. So you would need like a little kit that you could take soil with and keep the temperature warm, because if it gets too cold, then they won't grow. So that would be the first way to start, with a little like grow your own plant kit that we could take to Mars. If you really wanted to get ambitious, you could try to cultivate the soil and so on, but that would take a lot more energy and a lot more work. So you'd probably want to start small with the kit just to show that it'll work.
Thank you, Justin. Rain, would you like me to ask your question, or do you want to ask it yourself? Okay, I'll ask it for you. Her question is, what was the most challenging part of designing and executing that design with the Perseverance rover?
Wow, great question. Let's see. Jessica Samuels, how would you like to take that one for us?
Sure. There's lots of challenging parts in putting together a robotic spacecraft to explore another planet. And every team has its own challenge within its own part. And so really, just defining what we need to do for the mission, bringing it together, building the hardware, all the teams working together to figure out how we're going to operate it. And then, building a system to operate it, like you're seeing the team there in the control room. All of it comes with its challenges, and every team is able to work through it. And so no team is let off the hook of their own challenges in building this stuff.
Thank you so much, Jessica. We have opportunity for just a few more questions. Lesia, what is your question?
My question is, what do you suggest to children my age who want to become a NASA astronaut?
A NASA astronaut. All right, let's see. Steve Lee, how would you like to field that one for us?
Sure, yeah, that's a great question. A lot of people are really interested in becoming astronauts one day, and the biggest thing that the astronauts will tell you is follow your passion and be the best that you can be. Most astronauts have some sort of a technical degree, like engineering. A lot of them have a degree of medical background. We're starting to see some now, including one who used to work at JPL, who we're proud of, who has a geology background. So it tends to be a technical background, and then just be the best you can be, and then keep trying and be persistent in trying to get in there, and eventually you'll have a good chance.
Thank you so much. Leo, would you like to ask your next question?
Yeah, my question was, what types of computers do you use for project simulations? Just like any type of computer that you guys use for project.
Yeah, sure. Nick Rasachava, would you like to field that one for me?
Yeah, I can. So we actually don't need that much power to do our simulations. We simulate every single day. Every time we send something to the rover, we simulate it on the ground first to make sure it's safe. But the rover's computer isn't actually all that powerful. And so we can run our simulations on computers that are basically your standard day-to-day computers. In more specific circumstances, we can go to our copies of the rover that we have on Earth, but day to day, we just use kind of a desktop computer that's in our mission control area.
Thank you so much for that, Nick. Sophia would like to know, can you tell us how many times you failed at getting robots to Mars?
Wow, let's see. So robots to Mars. I think I'll ask Dr. Rick Welsh to answer that one, since he's been involved since we've sent all the robots to Mars, except for maybe the ones in the 70s. Those count too.
Well, fortunately, we've been pretty lucky from the NASA standpoint. Internationally, there's been a lot of other, countries that have tried and failed to get missions there, and we also had failed, back in the late 1990s. We had two missions, an orbiter and a lander, that both failed to reach Mars. But those are great learning experiences for us, right? It's all about perseverance. So we study those failures and we learn from them and make our future missions even better.
Thanks, Rick. Grayson, would you like to ask your next question?
So if you do find an alien on Mars, what would its name be?
All right. Well, just for fun, let's see. Gabe Matern, I don't think you've answered a question here. What would be your vote for the name that we would give the first alien that we found on Mars?
That is a fascinating question. Just off the top of my head, I'd hope that they were small and green with great big eyes, and I would call it Freddy.
I love that, Freddie. Owen would like to know, what type of plant might survive on Mars?
Oh, interesting. Ken Farley, would you like to take that one for us?
Very hardy plant. I don't think there are any plants that could survive without being in a container, as Justin mentioned earlier. But I suppose my vote would be for potatoes. Potatoes would be the best thing.
Potatoes, Martian French fries. That sounds good. So the last question for today from Celeste: have you ever come across a black hole during your mission?
Oh, wow, a black hole. Let's see. Jennifer, would you like to take a shot at that one, and then you can take us home here?
Well,
We have a James Webb going.
It's an interesting question. I loved black holes when I was growing up, and I loved studying them. And we don't actually have the instruments on the rover to be able to find a black hole, so we haven't found any black holes. But there are instruments, and we are continuing to find black holes in the universe, and they're fascinating things. So with that, I would like to close us off and say thank you and congratulations to every one of you. And now our mission team is going to congratulate you all. So everybody, give everyone a round of applause. I just know from reading your stories, from hearing your questions, and from interacting with you guys today that no matter what you choose to do, whether it's a passion for space or a passion for something else, you will all be successful because you're persevering and you overcome challenges and you do your very best. And so with that, we will play the messages from the rover once again. And thank you all for joining us today. Congratulations.
Thank you so much, Jennifer. And just for all of the awardees, you will get a fun mission pack in the mail in the next week or so. So be on the lookout for that. We also want to let nominators know that you have another round to nominate another student. And please spread the word to your other teachers and colleagues. To do that, go to go.nasa.gov/gotperseverance or #gotperseverance on social media. Thank you, everyone.